Hello children, this is the first question of in-text question and answer. So page number 230, that is, draw a schematic diagram of a circuit consisting of a battery of 3 cells of 2 ohms each, a 5 ohm resistor, a 8 ohm resistor and a 12 ohm resistor and a plug key, all connected in series. Now what we need to do, we need to draw a circuit diagram with 3 resistors. They have given 3 resistors. Those are 5 ohm resistor, 8 ohm resistor, 12 ohm resistor. These all resistors are connected in series. Along with that, there are 3 cells. 3 cells and I have given 2 volts each. Yes, and along with that a plug key. These all are connected in series. With the help of this information, we need to draw a circuit diagram. Now here is a circuit diagram. How to draw 3 resistors? This is a symbol of a resistor. One is 5 ohm, 8 ohm and 12 ohm. Each connected in series. One is one terminal. Second terminal of the first resistor should connect to the first terminal of the second resistor. Similarly, second terminal of the second resistor to be connected to the first terminal of the third resistor, and so on. Here are the 3 resistors, each one connected one to the other in a series. Then here they have given 3 cells. See, this is a symbol of a single cell. 3 cells, each one 2 volts each. Yes, along with that it is connected to a plug key, that is a key. Yes, now if you combine this all with the help of a line that is known to be a wire, then this circuit is known as a series combination of resistors. After drawing this, you need to put the arrow marks must. How to put the arrow marks? Always it should start from positive terminal. Conventional way of representing the flow of current in the circuit is positive terminal to the negative terminal. Now, this is a second question. Redraw the circuit of the above question. Putting in an ammeter to measure the current through the resistors and a voltmeter to measure voltage across 12 ohm resistor. What would be the reading in the ammeter and the voltmeter? Just recently, what diagram you have seen here, that is a connection of resistors in series. Same diagram, same, but they are asking to draw the voltmeter as well as ammeter. Along with that, asking to find the reading of voltmeter and ammeter with the given resistors and the batteries. Now, if we need to put the voltmeter, when we need to put, see here, the resistor and voltmeter to measure the voltage across a 12 ohm resistor. Here to measure voltage across 12 ohm resistor, that's the reason voltmeter to be placed above 12 ohm resistor. Yes, and ammeter can be connected anywhere in the circuit such that in a series combination it is showing same equal amount of current through the circuit. Yes, now we connected and we place the voltmeter across the 12 ohm resistor. Now what we need to find? We need to find the voltmeter reading as well as ammeter reading. What is voltmeter reading? Voltmeter reading is nothing but potential difference. Ammeter reading is nothing but that is current. Now, in order to find the current, what is the formula to be used? This is a formula from Ohm's law. V equal to IR, I equals to V by R. So what is I? That is a current that flowing through the circuit. So what is V? V is a potential difference. And what is R? The R is a resistance. Here the resistors are connected in series. First we need to find the equivalent resistance, then you need to put the R value in the formula. For that reason, first we need to calculate equivalent resistance. R is nothing but sum of the resistors which are connected in series. R equal to R1 plus R2 plus R3. Okay, here what is R1? R1 is 5 ohm. Next R2 is 8 ohm plus R3 is 12 ohm. So 5 plus 8 plus 12 is nothing but 25 ohm. Next, what is potential difference, that is voltage across the circuit? Sum of each cell, that is 2 volt plus 2 volt plus 2 volt is nothing but 6 volt. Now, what is the ammeter reading? Ammeter reading is nothing but the current. Current I equal to V by R. That is, what is voltage? 6 volt. 6 by 25. Simplify it and you will get the current that passing through the ammeter of the circuit is 0.24 amperes. Now, the reading of the voltmeter across 12 volt. The reading of the voltmeter across 12 volt. From Ohm's law, V equal to IR. Already here we have used V equal to IR. Just for differentiation, here we are putting V dash equals to I into R dash. Here what is I? I is a current in the circuit, that is 0.24 ampere, into what is R dash? R dash is nothing but, that is the resistor. Here only the resistor, here the voltage across 12 ohm resistor. So only if you take this resistor value is enough. So here V dash is equal to voltage, current is 0.24 amperes into 12. Simplify it, you will get the answer as 2.88 volts. Therefore 2.88 volts is the voltage across 12 ohm resistor. Here is another question related to series combination of resistors only, that is, study the following electric circuit and find the current flowing in the circuit, that is I, and the potential difference across 10 ohms resistor. Yes, so what is this circuit? This is a circuit of where the resistors are connected in series. What we need to find? First we need to find what is the current flowing in the circuit. Current flowing in the circuit, what is the formula? I equal to V by RS. What is RS? Resistor in series, or value of resistance in series. So I equal to V by R. We are taking it from the Ohm's law. V equal to IR. What is the V value? Already they have given in this diagram, that is V value is 3 volts. What is R value? Here R value they have given two resistors which are connected in series. First you find the equivalent resistance when the resistors are connected in series. Then you need to substitute this value. When resistors are connected in series, what is the equivalent resistance? Rs is equal to R1 plus R2. What is R1 here? 10 ohms. R2 20 ohms. 10 plus 20 is 30 ohms. Therefore, the equivalent resistance is 30 ohms. So, 3 by 30, which is nothing but 1 by 10, which is nothing but 0.1 amperes. Therefore, the current flowing through this circuit is 0.1 amperes. What is the second question? The potential difference across 10 ohm resistance. That is the potential difference across this 10 ohm resistance only. So, what is the formula? V equal to IR. What is the I? I is 0.1 amperes. So, same 0.1 instead of 0.1 here. For easy simplification, they have taken 1 by 10 value. So, 1 by 10 into what is R? R is 10. Why? Because they asked to find potential difference across only this 10 volt. That's the reason here in the place of R 10 to be substituted. Simplified 10 ones are and 10 ones are, we will get the potential difference is 1 volt. So here is another question. Two resistors, 3 ohm and unknown resistor. One resistor is 3 ohm, another is unknown resistor are connected in series. Across 12 volt battery, the potential difference is 12 volts. If the voltage drop across unknown resistor is 16 volt, voltage drop across unknown, the value is not given. There the potential difference is 6 volt. Then what is asking? Asking to find potential across 3 ohm resistance, current through the unknown resistor, equivalent resistance of the circuit. Now look at the solution. Here first you concentrate on the circuit diagram. In the question what they have given, two resistors of 3 ohm each. Here are the two resistors of 3 ohm each. Third resistor unknown means R, we don't know the value, so here we put only R. R is unknown. Next, what they have given? They have given that at unknown resistor, the potential drop they have given as a 6 volt. Therefore, first one, what we need to find? We need to find what is the potential across the resistor R1. Now, see, same current will flow through each resistor of series combination. In series combination of resistors, the current flow will be remain same. The current will be same. And one more information given, the potential drop across 3 ohm resistor will be V1 equal to V2. That is, this is information given in the question that how much amount of what potential difference we are finding at the R1, same potential difference, potential values will be observed at R2. That's the reason V1 is equal to V2. So, what is a total in a series combination of resistors, the current flowing will be the same. Therefore, the potential differences across each resistor will be different. Therefore, we are writing for a series combination of resistors, we can use this formula in order to find the potential difference across the system of resistors. V equal to V1 plus V2 plus V3. And in the question they have given that is voltage is 12 volts of the circuit. V1 that is across R1, V2 that is across R2, V3 that is across R3, that is unknown value of the resistor. And what is V3? They have given in the question, it is 6 volts. Now, as they have given, the potential difference across V1 and V2 both are same. So, in the place of V2 also substituted V1. So V1 plus V1 is 2V1. 2V1 plus 6, 12 equal to 2V1 plus 6. Bring this 6 towards left side, becomes 6. 2V1 equal to 6 and V1 equal to 3 volts. As V1 equal to 3 volts, then V2 also 3 volt. Why? Because V1 equal to V2. Next, what is the second question? Asking to find that is a current flowing through 3 ohm resistor. What is the formula of the current? Current I equal to V by R. What is V? Across a resistor. Across the resistor R1. What is V? V comes to be 3 volts. What is R? R is also a 3. So 3 by 3, which is 1 ampere. So what is the current flowing through 3 ohm resistor? The current flowing through 3 ohm resistor is 1 ampere. Next, what we need to find the value of unknown resistance. So from V equal to IR, formula R equal to V by I. What is V? V is 6 volt. What is V? V is 6 volts. Here unknown resistor, what is the potential difference at the unknown resistor? 6 volts. So here it is 6. What is I value? I value just now we found it is 1. So what is unknown resistor value? 6 ohms. Now what is the equivalent resistance? Equivalent resistance of the series combination of resistors, that is RS, series combination of resistors. RS equal to R1 plus R2 plus R3, as 3 resistors are there. R1 value 3 ohms plus 3 ohms plus R3 value found to be 6. Therefore, equivalent resistance of this circuit is 12 ohms. Now here is another question. Find out the reading of ammeter and voltmeter in the circuit below. Ammeter reading is nothing but the current, voltmeter reading is nothing but the potential difference of this following circuit. But once you study the circuit, here you are seeing 1, 2, 3, 4. 4 resistors are connected in series. Okay. And potential difference is measured across a resistor of value 2 ohms. And ammeter is placed in order to find the current in the circuit, and it is connected to the 6 volt battery. So whenever the diagram is circuit diagram is given, first you need to study the circuit diagram completely. Next, what we need to finding the ammeter reading as well as voltmeter reading. So what is the ammeter reading? Current. What is the current formula from Ohm's law? I equal to V by R. V value we know, that is 6. What is R value? All resistors are connected in series. So first to find equivalent resistance in order to substitute value of R here. What is the equivalent resistance? Sum of the values of the resistors. How many resistors are there? 4. Therefore R1 plus R2 plus R3 plus R4. Substitute the values. What is R1? 2. And plus R2? 3. R3? 3. R4? 4. 2 plus 3? 5. 5 plus 3? 8. 8 plus 4? 12 ohms. Therefore, what is the equivalent resistance of this resistor? Is 12 ohms. Okay. Now, what is ammeter reading? I equal to V by R. That is 6 by 12. Whose value is nothing but 0.5 amperes. What is voltmeter reading? Voltmeter reading formula is V equal to IR. I remains same when resistors are connected in series. So 0.5. And they are asking to find the potential difference across a resistor 2 ohm. Why? Because voltmeter is connected above 2 ohms. So here we need to find the voltmeter reading across the resistor R. So in the place of R, you need to substitute 2 value. So 0.5 into 2 is nothing but 1 volt. Now here is another question. Consider the following circuit. What is this circuit? See, all resistors are connected in series, and voltmeter is connected across 12 ohm resistor, and ammeter is connected in series, and these all connected to a battery of the value 6 volts. Now what would be the readings of ammeter, that is a current, and voltmeter? Voltmeter means that is a potential difference across 12 ohms only. When key is closed, that is when current is passing. Okay, give the reason and justify your answer. Now all resistors are connected in series, therefore find the equivalent resistance R equal to R1 plus R2 plus R3. Sum of all the resistors, that is 5 plus 8 plus 12 is 25 ohm. What is current? Current I equal to V by R, which what is V? 6 by R is 25. Simplify it, you should get this answer as 0.24 amperes. And next, what is the current flowing only through this 12 ohm resistor? 12 ohm resistor, 6 by, what is formula? Current equal to V by R. Okay, what is V? 6. Okay, what is the resistor? 25. Also 0.24. Here what we have observed that the total current that flowing through the circuit is also 0.24 ampere. If you want to find the current which is flowing through only this resistor 12 ohm is also 0.24 amperes only, which means that the current flow in a circuit when resistors are connected in series will remains constant. Hence, and what is the voltmeter reading? That is voltmeter reading when it is connected across 12 ohm resistor V equal to IR. What is I? I value is nothing but 6 by 25, that is 0.24 into 12. Simplify and try to get the answer as 2.88 volts. Yes, children, I hope you understood applications of series combination of resistors and how to calculate the current in the circuit and potential difference across any one of the resistor or across all set of the resistors.